Okay, let's use the law of cosines now to actually solve a problem. Remember that the law of cosines says c squared equals a squared plus b squared. So to that extent, it looks just like Pythagorean's theorem, minus 2 times ab times the cosine of theta. The important part in setting this up is to remember that you're either solving for this side or this angle. So in the law of sines, we had to have one complete ratio. We had to have sine of an angle over its opposite side, and then one other piece of information, either another angle or another side. The law of cosines allows us to solve when we don't have one of these complete ratios. So in two situations, it's usually referred to as side angle side. That's when we have a triangle and we are given side angle side. So if we know the measure of one side and the angle, we know the measure of the theta between those two sides, we can use the law of cosines to solve. We can also use the law of cosines when we have side, side, side. So we have a triangle and we know A, B, and C, but we don't know any of the angles. We can use the law of cosines to solve for each of the angles. So law of cosines can be useful in both of these situations. Where the law of sines, we have to have one complete ratio and one other piece of information. With the law of cosines, we don't have any ratio in either situation, but we can solve nevertheless using the law of cosines. So let's construct a triangle and solve. Let's say it's 6, 2, and 5 are the lengths. So we don't know any of the angles, but we do know all of the sides. So we can use law of cosines. In that situation, it's a side, side, side. So how do we progress? First of all, we have to set it up correctly using the formula. So we pick one of the angles that we want to solve for. We can solve for any one of them. I think it's easiest if you solve for one of the acute angles, and probably this one, because the side opposite is 2, so that's the smallest. This is the smallest side, so this will be the smallest angle. So let's solve for this theta. So we look at our formula and we plug in the information. What we're solving for, C, and this would be side C. We can set up either one of these to be the A or the B. We could actually call any of these sides anything we want as long as we keep this ratio, this combination together. So this theta that we're solving for goes right there, and this side goes here. So you have to keep this combination of side and its angle opposite. That's the key. You have to put those two together. So in this case, our side opposite that we're solving for the theta, we have side opposite and this is its theta, is 2. So we'd have 2 squared equals, and the 5 and the 6, the other two sides can be A or B. It doesn't matter, because you can see we're adding them together and then multiplying them together here, so you can do that in either direction. So we've called the 5 A. So 5 squared plus 6 squared minus 2 times the product of the other two sides, which is 5 times 6, times the cosine of the angle we're looking for. So now we only have one piece of information, this cosine. That's the only piece of information we don't have. Everything else we have filled in so we can solve. 2 squared is 4. 5 squared is 25 plus 36 minus 30 times 2 would be 60 times the cosine of theta. 25 and 36 would be 50, 61 minus 60 cosine of theta. So now we subtract 61 from both sides. So we'd have 4 minus 61. That will end up being 57. Will equal 60 times the cosine of theta. And now we divide both sides by 60. Oops, forgot that's negative 57. 4 minus 61 is negative 57. That would have been kind of a disaster. So we, oh, and I forgot, wow, I forgot this negative right here too. So we're dividing both sides by negative 60. Okay, hopefully I did that right. So now the negative 57 over negative 60 is just 57 over 60 because the negatives cancel. 57 divided by 60 equals the negative 60 divided by negative 60 here cancels, so we're at cosine theta. Now, if you know what cosine of theta equals 57 over 60, you could plug this into your calculator right now and do inverse of cosine and put this fraction in, and you would find the angle. But the way you would write that, if you wanted to do it properly, you would take the inverse cosine, so you can get theta isolated by itself on the right. So this would be cosine. That just means the inverse cosine, which is also called arc cosine, of this fraction, 57 over 60, will equal theta. All right, so the way we do that, this is the inverse on this calculator anyway. You're going to take the inverse cosine, which is arc cosine. So first you make sure you're on degrees. We're on degrees. Inverse cosine, it's the arc cosine, and now we just put in what we wanted. It was 57 divided by 60. So 18.194 is the angle value. That means that this right here is 18.194, and it kept going, equals our theta. So here's our theta, and that goes right there. That's the theta that we solved for, 18.194 degrees. So let's refer that back now to the unit circle. Make sure that you understand exactly what we did and how that worked. We just found that the 57 over 60 is the cosine of 18.19 degrees. So let's say 18.2 degrees. So if we drew an angle here, and we just said that angle is 18.2 degrees, is that angle right there. We drop this down. The length on the x-axis, because cosine is the length of the x. So this is 57 over 60, and I believe that that would reduce further to 19 over 20. So this point right there has coordinates, and those coordinates are, you can call that coordinate 57 over 60 for the x. The y we haven't calculated. You could also, if you divided 57 by 60, it comes out to 0.95. So 0.95 is the x. The y we don't know yet. That's another way to do it. So the length of this leg of the triangle is 57 over 60 It's also 0.95 units long. That is the cosine, that is the length of that leg of the triangle. That's what it means to find cosine. It's the length of the leg of the triangle, the x leg of the triangle.